Welcome to the today's episode of Talking Chaos Engineering. We're speaking with Andreas, and I'll let Andreas introduce himself.
For sure. Thanks for inviting me, Kartik. So my name is Andreas Krivas. I'm working for a company called Container Solutions, which is a cloud-native consultancy based in, well, headquarters are in Europe, but we have offices all over the world. And what I'm doing there, I'm working as a senior cloud-native engineer, mainly helping clients move towards cloud-native when it comes to tech, culture, or strategy. And for the last 8 months now, I'm working with a big company, which is an international organization around retail. And we're working there with chaos engineering. So I'm very happy to share what we've learned during this journey. And hopefully that will be useful for everyone attending this session.
Awesome. Thanks for that, Andreas. And yeah, from my side, hello everyone. I'm Kartik, maintainer of the Litmus project. So I've got a set of questions that we'll put to Andreas. We'll pick his brain on all things chaos engineering today. So the first question, Andreas, is I think continuous solutions, like you mentioned, is helping folks with their cloud native transformation. And I saw a series of webinar kind of events around what is cloud native that you've all been talking about, which I felt was just awesome, trying to explain cloud native and trying to take that to the common man. So, in your experience, what do you think is cloud native chaos engineering? How does that fit? What's the difference between what is traditionally believed to chaos engineering all these days?
Right. Yeah. So indeed, we are doing a lot of promotion about cloud native. Right. It has been a very big buzzword the last few years. Everyone is talking about cloud native, but I'm not sure how many people really understand what that term actually refers to. So if we take one of the possible explanations or one of the aspects of cloud native, it has to do with certain aspects of technology that enables high availability, scaling, right? We all work with this nowadays. A part of that is Kubernetes, orchestration, or containers, particular technologies that help companies reach the next level for their business. So when we talk about now chaos engineering comes from scientific principles, right? That it's not only about cloud native, it actually is way bigger than that and relies on the principles of forming a hypothesis and trying to dispute it and figure out things that are not obvious or you were not aware of. And I think that's particularly interesting for cloud native environments or systems, because if we think about it, right, we are in an era that cloud native systems coexist with, let's say, existing or maybe legacy IT infrastructure. That creates very complicated environments, right? You can have applications that they communicate with inside the clusters or outside the clusters with virtual machines or here and there and that. And then on top of that, you have components like service mesh or monitoring stacks, you name it, API gateways, things that, although they solve a lot of problems, they create a lot of complexity. And it's becoming increasingly difficult to understand what's going on, to really try to anticipate errors. And what we see a lot is no matter how much traditional testing you can do, integration tests, functional tests, unit tests, you name it, there are always going to be problems that you cannot find with these kind of tests. And one of the main reasons is you're not really testing in production. You're not really testing with real traffic and real users, which is, of course, scary for many companies, and that's understandable. And that's what I think cloud native chaos engineering particularly shines, is really testing the resilience of modern cloud native systems or hybrid systems, and revealing errors or issues that have arisen from the complexity of the systems all over the years. And I think that's particularly very interesting nowadays. We create more complexity, and now we have a way with chaos engineering to be more confident or increase the resilience of our platforms and be more in control.
Great. Thanks, Andreas. You touched upon hypothesis. I think that's a really important point. Something that you might say sort of separates traditional failure testing or system testing with chaos experimentation. So testing might, or the long-held view, or the question that comes up generally in the community is chaos is just another form of breaking things, fault injection. So one of the answers, or one of the thought process to that would be to say testing is more about how things, whether your functionality is really working in a specific way. But I think experimentation is more about the what. I think whenever you're deploying applications, you have some ways of some markers to say it is performing creditably, something that is largely termed SLOs. As part of the experimentation, you check whether these SLOs are being met, or they're being digressed from that, or how quickly they are returned to that optimal operating characteristics, mean time to recovery, mean time to failure, things like this. Hypothesis is big in chaos engineering as a science, like you said. So in the today's world of cloud native chaos engineering, and when I say cloud native chaos engineering, I'm trying to refer to the same operating approach, declarative way of defining your chaos, using things like custom resources, running chaos experiments within containers, in large deployment environments like Kubernetes. How do you see hypothesis coming or being viewed or being applied in these kind of scenarios?
Right. Yes. So the hypothesis is the part of the whole chaos engineering, let's say, experimentation is maybe the most important one, right? Mm-hmm. Usually, like you said, we do a lot of tests to verify things that we already know are failing, or things that we already know that they need improvements. Hypothesis, though, it's part of the chaos engineering just exactly because we are trying to identify also things we don't know. So we stress basically an expectation, and we try to see if that expectation is met. What I found from using chaos engineering in a cloud native environment the last few months, very important from a user's point of view is also how usable is also how easy it is to create a hypothesis, right? You can say, yeah, I think that if I do this, then that will happen. How does this translate to an actionable resource in Kubernetes? Is it a CRD, and how do I create that? How can I create as a user a lot of different experiments, and I'm very clear of what each experiment is going to try to disprove. And I think that's a very, very important point, and it will also lower the barrier of people using chaos engineering. You can imagine that it sounds quite scary for companies that they haven't done it so far, like breaking things in production. It's a very, very scary thing. So lowering the barrier of using chaos engineering and making it easy for someone to create a solid and clear hypothesis. And if magic is happening in the background, if it's a black box how this is executed, that's all fine. From a user's point of view, what I found very, very important is that it's easy to create an experiment, to define an experiment, and to execute it. That's quite important from our experience so far.
Yeah, and thanks for being quite vocal about it in the Litmus community. You're one of the prized members of the community, and that sort of led us to creating the Litmus probes in a way to define your steady state in a declarative manner in the CR. So there are different kinds of probes that we're trying to learn more from the community about what kind of checks they would want to do. How would they like to put their hypothesis intent on paper in a declarative fashion, and trying to create some tooling around it, or make the framework support those kind of definitions. Okay, having said that, you're one of the members in the Litmus community, in the chaos community in general, who is actually running chaos experiments in production in a big way. I know that from our interactions over the last few months. So how was that possible? And when I say, I just want to break this question down a little bit. How did you manage to convince the organization, the big retail organization that you're working with, to say that we will break things in production. Generally, there's a lot of barrier to that. There's a lot of hesitation. So how did you break through that from a cultural standpoint of view, and what were the sort of tools that you use to do that? And the other one was, what has your experience been like using Litmus in production? So I probably would like to hear these things.
Yeah. So yeah, the first question is indeed a very good one, right? It's something that is not an easy thing to achieve. However, there are a couple of things that are important for from the client's point of view. One of them is, sure, let's target production, but I need to be in control, and I need to know what's going on. I need to know that I'm able to stop everything if things are failing, or if I'm affecting production, right? So one of the big things that we really worked on and we emphasized is to reach out an agreement where we have a big red panic button that we can push, and then no matter what is happening, every experiment is terminated gracefully but very quickly, and there are no there's no spread of chaos or things don't become uncontrollable. Having this sense of control is very important from a client's point of view, right? So if things fail, I need to know that I can stop it, basically. So that's one thing. The second is security, right? All the experiments that we want to, all the use cases that we have, and we have to create experiments for them or develop experiments for them, we need to be absolutely certain about what are the security implications when it comes to the cluster or the applications, how we're going to leverage privileges if we need to have escalated privileges for some reason. How can we make it the least intrusive as possible, right? I've seen, for example, other chaos tools using, for example, the daemon sets, right? Daemon sets to have chaos injection possible in every node that the chaos tool is running. This was not our preferred option, right? With certain highly privileged experiments, we want to be, even if that involves more complexity in developing that experiment, we prefer to go in a more secure and least possible way to create chaos, right? So I think these two are very important. The sense of control that any experiment at any given moment of time, we can stop it comfortably and gracefully. Secondly, the ability to be flexible with security. We need, of course, sometimes we cannot do without a lot of privileges. At least also in these cases, we need to be as careful as possible. And I think the third thing is what I mentioned also before, is making it easy to use, making it very easy for someone to create experiments. I think in the past weeks, we've run hundreds of experiments in production, and people also started enjoying it or seeing the benefit. It also takes some time, right? You need to start using it to get comfortable with it if you haven't done it so far. But the feeling of control is even if it's just a feeling, right? Even if it's not something complicated from technical standpoint, but that feeling of being in control is very important. Now to your second question regarding Litmus specifically, we're really happy with Litmus so far, right? We did in the beginning of this project an evaluation of the open source tools that are out there. We looked at a lot of them. We looked at Chaos Mesh, Chaos Blade, Powerful Seal, Chaos Toolkit. We looked at quite a lot, but we went with Litmus, and there are a few reasons behind that. We really felt that we wanted something quite extendable. We like the ability to create your own chaos library in an easy way, right? And that's what we've been doing. Basically, we're creating our own Litmus runner, and that works quite well. But also the concept of having an operator behind with CRDs that you can define in a declarative way experiments were also important. What I particularly at least liked for Litmus, that I think is a differentiator, at least also for a client's point of view. Many tools are, speaking technically, right? They're targeting pods directly, right? They're finding the pods in a Kubernetes environment and they target those. What we liked also about Litmus is the ability to have one more layer of control, which is targeting the higher level objects, deployment or stateful set and all of that. and then targeting the pods. That gives us a better way of controlling things, especially when you are in a complicated environment with a lot of different namespaces, a lot of different tenants even. So yeah, it's things like that that made Litmus very promising. And we're really enjoying the interaction with the community of Litmus and with you and everyone else, right? I think we've been working very well so far. And we like that how vibrant is the community and how eager it is to help out each other. And I think that has really helped us last month.
Awesome. Thanks, Andreas. Really benefited with your feedback as well, and hope we continue that way. There's another question you touched upon: multi-tenancy. Really important in large production environments with hundreds of nodes. So you might have. When we say production environments, production can mean different to different groups of people. For someone like a retail organization, they might be storing their actual business apps, and they have got a lot of customers buying things and selling things on top of those platforms. So for the organization, that's production. But as for a group of people within that organization, the staging itself might be production, or they might have development platforms, several big clusters which they might have created, and the admins might have given off permissions to different namespaces, to different groups of developers or different departments within the team to be able to use those namespaces and run their stuff. And with the recent trends that we are seeing, where while chaos in production is the ultimate goal, that's what the principles of chaos states. There are a lot of people trying to do it at an earlier stage. Things are shifting left. People are trying to do it in CI/CD, or people are trying to do dev tests with chaos. So when you're trying to do chaos in this kind of a multi-tenant environment, generally, what are the practices you would take, or what are the precautions you would take? Or what are the expectations out of a framework that you would have to support chaos in a multi-tenant environment? Because you don't want to do a node delete, a node kill or a node reset kind of an experiment. If you do so and still not affect the other folks, how would you do it? Or what is the model like? I'm talking about the technical aspect and also the operational, the management aspect of it. People are view-only admins in some cases. There is an SRE who is managing the cluster and giving some permissions to a set of developers, service owners, as they call them. That's the term I sort of heard from Sumit and other folks into it. So generally, what is the environment like? How does chaos engineering really play there in those kind of environments? It's a very broad question. I sort of put in some 2-3 areas into it, but I just wanted to hear you.
Yeah, right. So I agree with the view that chaos testing makes more sense for production, but I really think that it's not only relevant for production. We also have been running in experiments in staging and also in development. What's different there is the type of experiments you run in those environments. Many experiments maybe rely on having real dynamic traffic to really see the effect. For those experiments where you can have this traffic in lower environments, then yeah, these experiments don't really make sense. But maybe experiments like scaling or killing pods or things like that could be relevant for also other environments, especially if you create load tests at the same time, right? Then there's also the arguments to incorporate chaos testing in the CI/CD pipeline. So wherever you're deploying somewhere, regardless of environment, you always do some type of chaos engineering test. So for me, the takeaway here is we should always be considering chaos engineering tests relevant for every environment, but we should really be again careful on the hypothesis. We cannot have the same hypothesis that we have for production for the dev environment. It has to be relevant. It has to be applicable to the environment we are applying to. So that's one aspect of it, right? Chaos experiments are relevant for everywhere, but we need to know. We need to be very sure what experiments are we want to run and why we want to run them in dev, what do we want to test in dev or in staging. Now, in terms of affecting others, right, that's usually why indeed you have an SRE team typically owning the chaos engineering practice or tools or framework, we can call it whatever. But there is an owner of that, and that's actually the reason, so that we know that what we are targeting is not affecting others. And I think that's important, at least at the earlier stages of an organization, until they become really comfortable. And also the developers are very in control of executing this type of tests. Until this maturity has been reached, I think indeed it's better to have an owner of the process and someone that controls it, because indeed, and it's fine if you make a mistake or two, but especially at an early stage, mistakes can also cost in terms of perception, right? If you make a couple of mistakes running chaos in dev, but you deleted or you drained a node that affected production, then people will start blaming the chaos engineering or chaos tester. Right? That's not what you want. You want a gradual adoption of the chaos engineering mindset, because it's, apart from a framework, is a mindset to always go and test in production. And that's also why one of the reasons we want to start from other stages and other environments, to make people comfortable before they test in production. Right? That's also part of the reason. It's quite a different mindset, and I think we need to treat it in a gradual way, and step by step. And when it comes to technical practicalities, there are ways where we can, you can isolate workloads on certain nodes just for the period of case experiments, right? If you're running critical nodes, you can put taints and things like that you can say, okay, all the production, if you have a multi-tenancy model that you have, I don't know, from dev to production in the same cluster, if this is the case, such cases, you can isolate some nodes and not running anything in production from those, and then target there, for example. There are ways where you can do that. I think that's the kind of the easiest part. The hardest part is to really, really make sure that the organization is adopting that in a gradual way, and you have at least a team that is in control of the process, and eventually the goal is to have everyone autonomous to create and execute their own experiments. That's the end goal, right? But that is a journey.
Right. Awesome. I think that sort of inspired us when we are sort of building the Litmus architecture to create experiment-specific RBACs. So we could use an all-encompassing service account which can do everything, and then create experiment-specific RBACs which can do just that experiment. I think that was one of the things. Awesome. I think that really fits in well. And I just reminded of one of the discussions that I was seeing on YouTube, where Nora Jones and a couple of other folks from LinkedIn and other organizations were talking about their chaos engineering practices. And one of the questions came up: there are some services we can't kill. So what do you do if you want to chaos on that? And the answer was, you do experiments, maybe like latency experiments and things like that, but don't do experiments that actually terminate them. Or, for example, I think that sort of ties into what you were saying. I think in the Kubernetes world, the self-managed clusters, maybe the kube server or HCD or things like that, be very careful when you're doing chaos on that, because you know that you're affecting a lot of folks. Right. The other question was, and I just have a couple more, this and another one, and then we'll end this. I won't take too much of your time. So the observability is really important in chaos engineering. Goes hand in hand. I think without observability, the consensus is you cannot step into chaos engineering. So how has your experience been doing chaos in production? What kind of observability mechanisms do you use, or what did you really set up in place before you started doing the chaos? Or what did you really look for before you started doing chaos?
Yes, absolutely. I think for me, the two most important aspects of chaos engineering is the hypothesis, like we discussed, and then is observability. Without proper observability in place, honestly, everything else is kind of meaningless, because then you are kind of blind of what's happening, and that's actually what makes it meaningful. So for me, there is also an important aspect to take into consideration when we talk about observability, is that observability needs to be very precise and very clear, but not too long or too extended when it comes to the chaos experiments. Because then what you achieve is shifting the attention from the actual target or the actual application under stress to the experiment, and that's where you start missing things, right? What our approach was, we need to make the chaos process, let's say the execution, as clear as possible from observability point of view, with clear logging and monitoring, but we don't uh, go, let's say, and have an overkill of information or an overload of information for the user, because then they're kind of lost. Do I look at the experiment? Do I look at the application? And we want them, their focus to be on the application behavior or the system. And I think that's very important, and that's also hard to nail 100%. How do you create very thorough observability without having a lot, without wanting to create too many things, right, or too verbosity, things like that. And I think that's very important. So in our process, what we have been doing is we execute the experiments with teams. Um, as kind of like together, because it's just also the beginning. We are focusing on making sure the experiments are running, and if there are errors in the experiment execution, we are the ones following up. The team doesn't need to know, and the team is focusing on their application. This has proven quite useful, and then they can focus on what actually is happening, which is the main point, and we can focus on making sure that at least the experiment is running as it should. So yeah, it's not an easy thing, right? You need to have your focus also on the experiment, but also on the results. But the key point are the results. The key point is this is what you will see if things are running, right? I've heard people saying, the experiment worked. They meant though that the execution worked. They didn't see anything failing. So for me, that's actually not a good experiment. If you don't see anything failing, probably you need to tweak it a bit more, or maybe you have a great application. But yeah, the perception of when experiment has worked for me is when you found something you didn't know, then it has worked.
Absolutely.
Yeah.
Awesome. I think we just have one more question to end things on a lighter note. So we've heard of this people chaos. That's sometimes you have this one person in your team who knows everything about infrastructure, knows everything, all the IP addresses, or probably knows what system is doing what, and probably knows all the SLOs on top of his mind. So, and also the incident response, he's probably the first person to come and sit there and solve issues. And you just go kidnap him for a day and just see if the processes and documentation are good enough to handle things without that person. So, do organizations really adopt these kind of things? Is that something that's happening in the as a chaos engineering practice, or is it something that's still theory?
Yeah, so that reminds me also of a very popular book that has kind of influenced the old DevOps movement, right? The Phoenix Project, and if you look there, they have exactly this person called Brent, and Brent is the guy that solves everything, that knows everything, and when he's sick or not available, things are falling apart, right? So this is a very very accurate paradigm that we see in many companies. There are these few people or one person that is always being called to come to the rescue, right? But I think this is kind of a cultural problem more than technology, right? This is not technology's fault. Also in cloud native world, you can have this person that knows all the configuration of your cluster and all the specific airbags and all the network policies and all of that. You can still have it also in your world. It's more of a cultural shift that is we need to do there. Chaos engineering, when let's say we assume that a company, maybe like Netflix and other companies, that they really be doing a lot of chaos engineering. If you have embraced that as part of your culture, then it inevitably helps to really shine light on the problems that are hidden and maybe one person knows. Then, though, if that will change or not, it's part of the culture, right? You can still have that person saying, "Hey, can you look at this? We found this," right? The chaos engineering will not help you there. Chaos engineering will help you really shine light on the issues that you have. And then it's the culture of the company that needs to, embrace failure. One thing, right? Because that's what chaos engineering will point to you. It will point what fails, and you need to embrace failure, but then also put time and effort to not consolidate knowledge like that. That's a very very typical problem and also hard to solve once it's there. Chaos engineering can help breaking that pattern. But then it's also a lot of cultural work and transformation that an organization needs to go through to be able to change this mindset, company-wide. Yeah, but it's a good observation.
Cool. I think Git as a single source of truth and all the GitOps, the latest practices, probably in the cloud native world, it helps mitigate this problem to an extent. But again, in spite of all this, you will still have that few people who are know all guys, and that's a cultural thing that we need to fix. Rightly said. And yes, I think with this, I think we'll wrap up. Thank you for sharing your time and insights on chaos engineering. And thank you for all the work that you've been putting in terms of reviews, PRs, contributions, and feedback on Litmus. So hope to work with you moving forward and grow the community, and hope everyone adopts cloud native chaos engineering. Thanks for your time today, and go ahead, Andreas.
Yeah, thanks as well, Karthik. It's been a really pleasure working together last few months. I think we've made a lot of good steps together, growing Litmus, but also growing the adoption of cloud native chaos engineering in the community. Really happy to see also the incubation news of Litmus. So I really wish you luck there. And I think, it's chaos engineering. I keep saying that it's here to stay. It's just inevitable to have something like this to really put the resilience of your system into a real test. And I'm happy to continue working with the community, and hopefully we're gonna keep improving things. And hopefully by this time next year we're gonna have even wider adoption of these practices. So yeah.
Thanks, and have a great evening, Andreas.
Thanks, you too.